Okay. SQL. SQL or sequence. What is SQL? SQL stands for Structured Query Language. SQL stands for Structured Query Language. So what is SQL or what is SQL? It is a struct. S suggests for structured, as the name suggests. Stands for structured. Q for query. This term query is very important. Query. And L is language. So from L, we already know that this is a language. What type of language? This is a programming language. Obviously, this is a programming language. What kind of programming language? What is it used for? What is its application? Is query. Q stands for query, and A stands for structured. So, why we use query? Why we use query? Why do we query using SQL? Why do we query using SQL or SQL language? To deal with data. To deal with data. So basically, whenever you are dealing with data, this is the most fundamental, this is the foundational uh, skill set you have to acquire. Okay. SQL is the most fundamental. This SQL is the foundational skill set that is in common for all the people dealing with data. Okay. The SQL is the language which everyone has to know. Everyone has to learn if you are going to emerge into the field of data. Okay. If you are going to dive into the field of data, you have to know SQL at first. Okay. Now, as we all know that SQL is used to deal with data. So everything that we are going to learn is going to be based on data. Everything is going to revolve around data. So what is data? So at first we have to know what is data. What is data? What is it? In practical life, we see numerous types of data. Okay, for example, forget about calculations or mathematics. That is data we all know. But in day-to-day life, for example, you are making some kind of chart, or in our books. In our books, there is indices. There are index page. In index page, you have a heading called index, and under index you have two columns. One column is the chapter names, which consists of the chapter names. Another one is page number, page number. Another column is page number. So chapter column uh, this also data. This table consists of data. Now I have used another term, table. And during while I was talking about the term table, I also used another term called column. These all are very important terms, terminologies. Now, this whole chart consists of data, isn't it? Any kind of information, may it be numbers, may it be any alphabets, or any special cases, any types of information is considered to be data. So data is a way of storing or writing information, isn't it? Now, in uh, in hard copy, how can we store data? How can we store data? First approach is you can store data in hard copy, or you can store data in soft copy, in soft format. What is Hard copy is a tangible format, isn't it? Hard copy is a tangible format. It is a tangible asset. It is a tangible asset, or tangible thing. We can touch. We can touch this page. We can read this page. But in computer, you cannot touch the data. You cannot. You can read the same thing, but you cannot touch it, isn't it? So it is intangible or untangible. Intangible. This is intangible. So whenever we are dealing with intangible data, or we are storing the data, fetching the data, we are retrieving the data, we are exploiting with the data, we have to store the data somewhere. Somewhere we have to store the data. Then so when the data storage comes into the picture, we talk about database, we talk about data lake, we talk about data warehouse. All these terminologies come into the picture, isn't it? So what is database? Database is a type of storage. Database is a type of storage, or a room. You can consider a room. For example, this is furniture. This is a furniture. This is a laptop. This is a board. Everything is content into this room. Everything is content into this room. So this room is a database. Or take a larger picture. Take a larger picture. For example, this home, this house. This house consists of many rooms. This house consists of many rooms. Now this house is a database. This house is a database, and all these rooms are tables. So where do we construct table? We create tables. Where do we create tables? We create tables inside database. We create tables inside database. So all these rooms are built inside this home. So this home is a database, and all these rooms are tables. All these rooms are tables. And this particular bottle, this mug, and this board, this duster, this marker, including myself, everything. Not myself, because I can move to an. Okay, right now I'm in this room, so I'm also an element, or you can say we are all data set of data or information, isn't it? So take the previous example again. This is the index page. So this book, whenever you are taking a book and you turn the pages, at first you get the index page. So this book is the database. This book is the database. This book is the database. Inside the database, we have tables. Index is the table. So the table name will be index. The table name is index. The table name is index. And this table index consists of many columns. This table table consists of many columns. And all columns have their corresponding names. All columns have their corresponding names. All the attributes of the columns must have a name associated with it. All columns must have a name associated with it. So chapter is a column, page number is another column. Okay, there are two columns in the index page. Okay, and under index page these columns we have many rows, isn't it? Under columns we have many rows. For example, the first chapter is intro or introduction, intro, and the page number is 1. It is starting from page number 1. Now or page number 3. Page number 3. It is starting from page number 3. Now next page is type hello. Type hello or hello world. This is starting from page number 5. Okay. Now, considering SQL. Okay. Next, so the second chapter is what is SQL? What is SQL? What is SQL? Now, data type. Third chapter is data type. Third chapter is data type. It is starting from page number 10. So these are the rows we know. Actually, we all know the concept of table, uh, column, and rows. We have the concept. We can tell that if we are given a table, we all can tell that okay, this is a table and these are the columns and these are the rows. We can identify that. We may not write it in a the correct definition, but we can identify what is column and what is row. Okay. That is enough. That is enough. Okay. Nobody is going to ask you what is table, what is column, what is row, because they know that since childhood we all know that structure of table. We all know what is column, what is row. So they are not going to ask such silly questions. Now, now we have understood the structure of table, what is table, and on a high level. On a high level, we have already understood what is database. Database is somewhere somewhere. Nah, database is something where we store data. Okay, database is a storage type of storage where we store the data, and table inside database we create tables, and a table consists of columns and rows. Consists of columns and rows. All columns have their associated names, and under the columns we have multiple rows, isn't it? So this is the basic structure of a column. Sorry, a table and database. Database and table. Now, so to start with coding, we have to create database first, isn't it? The first terminology we learned was database. The first terminology we learned was database. So we have to create a database. That is quite obvious. We have to write a data. We have to create a database. So how to create a database? It is very easy. Create, create, create database. Oh, okay. Create database. Create database. Now we let us name it book. Let us name it book. Keep in mind that you don't you never use any particular specific terminology which are already present in this language. For example, I cannot name it index. That will create ambiguity, or that will create contradiction or conflict, because it is a machine. It is not smart enough. In future, they will be smart enough due to emerging artificial intelligence technology. But right now, wherever we are standing, computer is not smart enough to identify the difference between the terminology index and a table named index. So you have to keep in mind that you never use a specific terminology which is already present in the language. It is not only about SQL. It is applicable for all languages. It is applicable for Python, Java, C, any language. You should keep in mind that you should never use any specific terminology, but it should be meaningful. It should be meaningful. It should be meaningful so that you can understand, you can comprehend. Okay. Got it. So this is the index. How can you write? So the create table we have created. Now we create database book. You log into that server. Okay. You install the specific SQL server tool. Okay. Maybe SSMS or PG admin or anything. MySQL. Then you log into that server, particular server. Then you type create database book. Fine. It will say that if everything is fine, then it will show that database has been created. Database has been created. It will show the database has been created. So right, okay, the database has been already created, but you cannot directly create, go to the next step, or you cannot directly create table inside it. We know that after creating database, we have to create table, but you cannot directly go to. You have to write use. You have to write use database. Use database. What is the database name? Use book. Use book. So book is the no. You have created the database. Now you are going to use the book database. After you run this line, use book, it will go inside the book database. Now, whatever you create or whatever you perform, it will by default will be created inside this book database. Okay. Now, how to create table? Same. Like this, create database, it will be create table. So SQL is very easy to learn initially. Than other languages, because it is very easy to understand. It is very user friendly. Create table, create database. Everything is not going to be like that, but initially it is very easy. Create table. Create table. Now the table name will be INDX. INDX is not there. It is not a specific terminology. So I can use that. INDX. INDX I can use. Okay. INDX. Now there will be a bracket. Inside bracket, first bracket one open, bracket close. Inside this bracket, I will define the structure of the table. If you write create table index and you want to write that structure later on, that will not, that is not going to work. You can update it. You can update it. You can alter anything. You can update it. That is fine. You can alter. You can update values. You can alter table. You can do that. But when you are creating the table, you have to define the structure of the table or what. And now I have already told you what is the structure of how can we define the structure of the table. There are columns. At first there are columns. Okay. So table consists of columns. Rows are basically informations. So if there are 100 records, 100 records, then it consists of 100 rows. That is secondary. Row we are not going to create. We are not going to create rows. We are going to create the table with columns. Inside the column we will insert data. Inside the columns we will insert data. And that is going to be considered as rows. Okay. So table is nothing but collection of columns. If there are no rows, still this is the table. Okay. Row is secondary. You have to fill data to create. When you are inserting data, you will have rows. But before that, the structure of table consists of columns. You have to keep in mind. An empty table can be there. Okay. There can be an empty table. There can be an empty table. There can be an empty table. An empty table does not contain any row, but it must contain columns. Otherwise, it is not a table. It will not be called a table. Without rows, how can it be called a table? The first condition is column. So we are going to create column. You see how we are going to write that. Okay. For example, the first column is call1. Call1. Okay. After that, we are going to write the metadata information. We are going to write the metadata information. What is metadata? Metadata is nothing but data about data. Data about data or data on data. Data about data. So, for example, these columns are in data. These columns are data. Now, we have to write the metadata about this column, which means what type of column is this? What type of column is this? What will be the data type of the column? So these columns are going to contain data. Later on, we are going to you are not creating a table for show or for only show, isn't it? You are not going to create a table for fun. In real life, you are going to create a table for some use. So you are going to store some data. That is why you are creating this table. So you are going to insert some data inside this table. You are going to insert some data inside this table. So what type of data it is going? This column 1 will consist of. What type of data this column 1 is going to consist of? That we have to define. So it will be data type. So data type we have to write. Data type we have to write. And then we can also write constraints if we want. What is constant? I will discuss later on. What is constant? I will discuss later on. Constraint. Okay. Similar structure will be there for other columns also. Column 2 and then data type, and then if there is any constant, then we will write. Constant is not mandatory. There may not be any constant. There may not be any constant, but data type should be there. At least you have to define some kind of data type. For example, there is a data type called text. We'll discuss that in detail later on. But text, there is a data type called text, which is limitless, which is basically limitless, and it can consist of any type of alphanumeric. It can be number, it can be hashes, or any special cases or any letter. It doesn't matter. So you can store multiple pages of data inside text format. That also you can write, but you have to define. For example, you don't have any restrictions on data type. Still, you have to write that okay, I don't have any restrictions on the size of the data. I don't have restrictions on the type of the data, but I simply want to store all types of data. Then you can write text, but you have to type it. Now dot 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 dot, it is called n. This is the nth column, and there will data type, and if there is any constant, then okay. Table has been created. Now next step, we all know. The next step we all know. We have to insert the data, isn't it? We have to insert the data. Okay. We can talk about the select statement also, because we have already created this table. We can show the structure of the table. But after inserting the data, the data will be shown. Okay, just remove it. Now, for example, you want to select. Sorry, you want to view. You want to display that table. This is an empty table. This is an empty table. This is absolutely empty table. There is no data. We haven't inserted any data inside this table yet. But we want to display the empty table. How can we display that? Using select statement. So select statement is the statement or terminology used to display the table. To display the table. So what we are displaying? We are displaying the table. So this is select statement. Select. Now the syntax will be select. There is select, there is from, and there is table name. Now, in between select and from, you have to define, you have to write the table names. You have to write the table names. This is the table. So select from table name. This is a table name. Table name. Tab name. Okay. Table name. So select from table name. And in between select and from, in between select and from, you have to write column names. Now, if you want to display only chapter column, if you want to display only chapter column, then you have to write select chapter. Or in previous example, I wrote call 1 and call 2. In previous example, I wrote call 1 and call 2. Call 1 and call 2. So select call 1 from table name. If you want to display column 2, then I will write call 2 from table name. Okay. Now I want to, if there are n number of columns and I want to display all the columns, then I will write star. Star stands for all. Select star from table name. Select star from table name stands for select all from table name. Select all from table name. So star stands for all. And table name is in index here, but I'll create the table again because I have written the structure of that table only. Vaguely I have written the structure of the table only. I haven't defined that table in detail, isn't it? On a very high level, I have explained the structure of the table. How to define the structure of the table. Then I have written data type, but I haven't mentioned the data type. What is the column name? I haven't defined. So then that one I am going to do right now. But before that, I have to discuss about the data types. What are the data types we can deal with? Okay. So data type is very important before creating any table. You already understood that for creating a table, you have to define the data types at first. So data type and constraints I will discuss before jumping into the previous part again. Okay, I'll go back to that part after this. So data type. What are the data types you can think about? If I ask you, what are the data? If I talk about data, what are the data types you can think about? So the first type of data that comes into our mind is numbers. Numbers, isn't it? The first data types that comes into our mind is numbers. When we started to learn initially when we were toddlers, the people around us or our parents used to teach us, okay, this is one, this is two, using fingers. They used to show that this is one pen, this is two pens, this is three books. Okay, so 1, 2, 3, 4 we learned at first. Then we were jumped into ABCD, which is basically character types. So at first the number comes into the picture, then we move to the character types. Now let me remove everything from here. Well, apart from SQL, this heading, I am removing everything from the board. So this is SQL. Absolutely fine. Now, number. So what is number? I don't have to talk about what numbers. I don't have to talk about the definition of numbers. We all know what's number. The concept of number is sufficient enough. The concept of number is sufficient enough. You don't have to define it explicitly. So 1, 2, 3, 4 to 1 crore, 1 million, 1 billion, 1 trillion. 50,000, 596,123,59924. Anything is number. All these are examples of numbers. Now, but in a table, there should be a limitation, isn't it? Number cannot be limitless. You are storing a data, your storage is limited. Your storage is itself limited. So you cannot store unlimited number of data or unlimited numbers. If you think that you are going to store a number inside a table and that is that contains 100 digits, that contains 100 digits, that is not going to work. That is not going to work. That is so huge that you cannot store. Normally you cannot store, isn't it? 100 digit is extremely huge. You cannot deal with such a large number. So there are different types of data, and if we talk about the number type of data, whatever you call it, number. There are different types. At first, 1, 2, 3, 4, 5, 6, 7, 8. We didn't learn 1.5. We didn't learn 2.8. When we were toddlers, we learned it later on. So at first we learned integers. What are these? These are integers. What are these? These are integers. What are the integers? 1, 2, 3, 4, 5, 6, or -1, -2, -3, -4. These are the integers, isn't it? So these are the integers. So number. So integer is the first type of data that comes into the picture. Now, as I told you, that there can be multiple types of storages or data size. Depending on the size of the data, you can divide it in. You can classify it in three types. Integer types. What are the types? Small int. Int stands for integer. Then integer or int or integer. Then that depends on the language. In PostgreSQL, you write integer, the whole thing, but in some languages you write int only. And big int, then big int, then big int. Small int, big int, integer, big int. You know the normal big integer is basically the medium one. Small one is the smaller than integer, and big int is bigger than integer. That is why I have written small and big. So small int is 2 bytes. Now I have to write. I have to understand what is byte. I have to understand what is byte. You know what is binary number system? Have you dealt with decimal, binary, hexadecimal, So we know that usually when we are dealing with normally in real life, when we are dealing with numbers and we are doing calculations like addition, multiplication, subtraction, multiplication, division, all these operations, we are basically dealing with decimal number system. So decimal number system is the standard number system. Decimal number system is in real life, decimal number system is the normal standard number system. But in case of electronics or in case of computers, binary is the language, machine level language. Binary is the machine level language, or binary is the machine level standard for mathematical operations. Machine level standard for mathematical operations. Computer or your processor or your chip doesn't understand decimal system, or they deal with binary system. So there are mechanisms inside the processor, or mechanisms inside the chip, which makes it capable of dealing with these decimals. At first convert it into binary system, then dealing with binary, and then converting into decimal and display it as decimal, isn't it? So in decimal we have only two types of number. In decimal we have 0 to 9. You can write numerous numbers. You can write 100 digits of numbers, but it will consist of 0 to 9. All the digit can go from 0 to 9. The digits can, each digit can go from 0 to 9. So only 0 to 9 digit, there are 10 digits. Only they are 10 digits. That is why it is called decimal. There are 10 digits only. That is why it is called decimal, because it contains 10 types of digits. 10 types of digits. And in hexadecimal we have 16. Hexadecimal 16. Hexadecimal stands for 6. So 16 digits. 0 to 9. There are 0 to 9. Then A, B, C, D, E. A, B, C, D, E, F. From A to F is also there. If we, in the hexadecimal, if we have to write 15, we will write E. We will write E. And the base will be obviously 16. The base is going to be 16. So, the base actually defines the number system. Base defines the number system, or the number of digits that is present in the system is the base, and that implies the number system we are dealing with. So in case of decimal, though whenever I am writing 2 plus 5 equals to 7, basically I am dealing with decimal system. Okay, so 2 to the base 10, 5 plus 5 to the base 10 equals to 7 to the base 10. This is the reality. This is the reality, but we don't write that. But in decimal, if we are dealing with binary, we have to write that the base as 2. We have to write the base as 2, because this 2 shows that in binary system there are two types of digits. One is 0, another one is 1. One is 0, another one is 1. In electronics, you will in digital electronics, you will deal with 0, 1 only, and other number systems also, but mostly 0, 1 is very important, because binary system is the key. Binary system is the key. Okay. In electronics, what happens? The low signal is considered 0 and the high signal is considered 1. If current is flowing, if the light is on, if current is flowing through the circuit and light is on, then it is 1. If the light is off, or the current is not reaching the light flowing through the circuit, then it is 0. So 0 is off, 1 is on. There can be other conditions also, but mostly 0 and 1 is used for that in electronics. And in logical operations, when I'll be talking about logical operations, I'll again discuss about the concept of gates: NOR gate, OR gate, AND gate, NAND gate, XOR gate, all those things. On very high level, I'll not draw everything, but I'll show you that it is basically the same thing. The logical operation, these logical operations are performed using circuit. That is why we are saying that this is the gate. AND gate, OR gate. Forget about gate. That is electronics thing. That is explicitly totally electronics thing. But we are performing mathematical operations or logical operations. Okay, so then that I'll discuss later on. But so 0 and 1 are the digits in binary. These are the two digits we will deal with. And 0 and 1. If I write 0, 1, it is 1. 2 is 1, 0. 2 is 1, 0. 2 is 1 0, 3 is 1 1. Why? Because the index, first index is 0, second index is 1. So 1 into 2 to the power 0 is 1. Now 1 into 2 to the power 1 is 2. That is why 1 0 is 2. 1 into 2 to the power 1 plus 1 into 2 to the power 0 is 2 plus 1 equals to 3. That is why 1 1 is 3. So this is the way you define binary system. So 2 bytes means so these are the bits 0 1 1 1 1 0. These are the bits. 0 is a one bit, 1 is another bit, 1 1 in 1 1 1. This one is a 1 bit and this one is another bit. So there are 2 bits. Okay. So these are the bits. These are the bits. Okay. These are the bits. Now in what is byte? A byte equals to 8 bits. A byte equals to 8 bits. Byte equals to 8 bits. अच्छा देखिए byte equals to 8 bits. Byte equals to 8 bits. Okay, byte equals to 8 bits. So 8 bits equals to 1 byte. For example, 1 0 1 0 1 1 1 0 1 1 2 3 4 5 6 7 8. Okay, wait. 1 0 1 0 1 1 1 0. This is a number. This is 1 byte. 1 byte of, okay. So like that. So 8 bit consists of 8 bit equals to 1 byte, and small int consists of can hold 2 bytes of data. Small int can hold 2 bytes of data. Integer can hold 4 bytes of data, and big int can hold 8 bytes of data. 8 bytes of data. And 2 bytes is approximately around 32,000 something. Okay. You don't have to memorize it. You don't have to memorize it, the number. Maybe in schools or colleges, they can ask you, they can tell you to memorize it, but you don't have to memorize it in real life. But big int you can never memorize. It is so huge. So if you know that small int can hold up to 32,000 something, it is 32,767. From 32,768 to 32,000 minus 32,768 to plus 32,767. Why it is 68 in negative and why 67 in positive? Because there is 0 also there. 0 is also a number. In positive, they are considering 0 as it will be a so 32,768 times 2 you can do. So that is the total number of numbers you can store, right, in small int. Okay. So 1 byte equals to say 32,768. That you can calculate. Up the range of 1 byte. Now it is 2 bytes, that is why we can write from negative to positive. Now in integer the range will be much bigger. It is not double. It is not double. Double the size means it is going to be multiple. Okay. It is going to be multiple. And it can hold huge amount of data. 1 2 3 4 5 6 7 8 9 10. So 10 digits. It has a range of 10 digits. It can hold a number up to 10 digits also. 10 digits means in 1 crore uh, it has 8 digits. In 1 billion, it has 10 digits. So it can hold up to, because 100 crore is 1 billion. So it can hold up to 2.14 billion from negative to positive. And forget about big int. It is even much bigger. So in in practical life you can write integer right away you can write to be integer. Big int is not required. But if you think that number is going to exceed 1 billion, 2 billion, which is not practical, which is not practically possible. 2 billion is not going. It is not going to exceed 2 billion. But maybe in some cases it can hold the number up to that much of uh, value. For example, you are dealing with Ambanis and Adanis, account of Ambanis and Adanis. For example, you are dealing with the account of a bank is dealing with now account of a Swiss bank is dealing with account of Ambanis, Adanis, and all the multi billionaires, the richest people. Then their account holds numbers bigger than billion. In that case, maybe they are using this big int. In the backend, obviously they are using big int. If the data type is integer type. If they are not using integer type, then that is different case. And as we all know that it is not going to be integer actually, because currency is not always integer. It can hold decimal numbers also. So what is decimal? So after decimal, we will be dealing with okay. Now in integer, if we define the data type as integer and leave it like that, it is not going to hold any number. We have to manually insert data, and while inserting data, we have to keep in mind that okay. Now I have to, for example, there is another column called ID. This is a column called ID. Under ID, we are going to insert data in incremental manner. It is starting with 1, and 100 record will have 100. Okay. Then if we take it as integer, each time we insert data, we have to manually handle the data. We have to manually handle this column. We have to keep increasing the value in that way. But if we want it to be auto incremental, or if we want it to increase automatically, then we have to use serial data type. Okay, we have to use serial data type. How? So serial is another data type. It also holds integer type of data, but it is auto incremental. So serial type is also same. There is small serial. I know this is a very big name. Small serial. Then normal serial. Serial is serial. And then big serial. The same size is also the same. But the nature of the data type is different. It is auto incremental in nature. So 2 bytes. This is 4 bytes. And this is 8 bytes. Okay. Then, so small serial and big serial. 2 bytes, 4 bytes, 8 bytes. Okay. Done. Now, the range will be same. And in case of serial, it is not going to hold the negative type. So you can say that it is not integer in that sense. It is not negative integer. It doesn't hold the negative integers, but it holds the positive integers or the positive numbers, positive integers in a sense. So 1 to 32,767 it can hold. Now, after that number, we have after integer we have another type of numbers, which is floating numbers, floating type of data, floating type of numbers, floating type, floating type. If you are learning SQL, obviously you have learned C language, C programming language, or any kind of programming language before this. In that case, when we are in C programming or C++ or Java, Python, or in all these languages, when we define data type, we write int. For integer, we write int data type. And for decimal type of data, we write float, isn't it? We write float. These are floating types. What is floating? For example, 1.10.56. Okay. This is the point. This point is very important. If we remove this point, this 10 and a half, approximately this 10 and a half, 10.556 or 10.6, what this approximation, but this 10.5 or 10.6 is going to be 1056. This point is so important. This point is so important. So this is the decimal data type or floating type of data. What are the data types in floating type? One is numeric, and decimal, Right? Numeric and decimal. Right. So, what is the specialty of numeric and decimal? At first, the storage size is variable. The storage size is variable. What is variable? Variable means which can vary, which is not constant. One thing is constant, which constant means it cannot change. Variable type means it can change. There is flexibility. So, in numeric and decimal, it is not defined that this much of data will be there. Only this is the range, and you cannot increase it or decrease it. So you can increase or decrease according to your requirement. So it is variable storage. Okay. And number range is also there, but ideally you should not be bothered about the data size. Okay, because numeric, decimal, these data types can hold huge number of data, which the range is so huge that is beyond our practical application. That is beyond our practical application. So we are never going to exhaust the range. We are never going to exceed the range, or this range is not never going to be exhausted. Okay. So forget about the range. It is variable storage. Now, another one is real data type. What is real data type? Real data type is fixed. This is a variable storage. Now this is fixed. The size is fixed. 4 bytes. Numeric decimal can be smaller than 4 bytes or 2 bytes. But in real data type, it is 4 bytes. It is fixed. Okay. And this 4 bytes can provide us 6 decimal digits precision. It provides us 6 decimal precision. Okay. 6 decimal precision. So we can have after decimal, we can have precision up to 6 decimals. It can be 10.56 to 1 3 1 7, like this, 6 digits, up to 6 digits, precision up to 6 digits. So in real we can have 6 digit precisions, and 4 bytes is the range. And double precision, there is double precision, double precision, double precision. It, as the name suggests, real is 4 bytes, so double precision is 8 bytes. Double precision can hold up to 8 bytes, and it has 15 bytes, 15 decimal precision, or 15 decimal digit precision. So it can have up to 15 digits after decimal point. That much of precision we can have. Floating type is also done. Now, next type of data is number we have done. Now it is character types. Now it is character type. Character means alphanumeric. It can hold letters also. It can hold numbers or special cases or anything like that. Any symbols. But alphanumeric means everything. How can we store that? Okay. One is char in. What is char in? Char is character. I'm just verifying whether I'm missing anything on. So char n. N is the, so in character type, it is a fixed length n. It is a fixed length n. Okay. It's a fixed length n. Which means char n, this char type of data or char data type has a fixed length which is n. So if I write char n, it can hold, it will hold 10 characters only. It will hold 10 characters only. So number of type, number of characters is defined inside the bracket. Now, then, if we want, it is the fixed characters or fixed number of characters. If we want variable type number of characters, then it is varchar or varchar or varchar. Varchar or varchar. So var means variable, char means character. Variable character types or varchar. Variable character types or varchar. So it is variable. We know that it is variable. What is variable? We have to write n. We have to write the number of n, but it is the maximum. It is the maximum value of n, or it is the maximum value of characters. Varchar 100 means it can hold less than 100 also, but it cannot exceed 100. So maximum value will be 100. So you can store anything within the range of 100. Within the range of 100 characters. Okay. Now there is, I told you earlier also, there is text. I told you earlier that text is the format which can hold unlimited length of data. Unlimited length of characters. Unlimited length of characters. So char n is the first type of character data type, which is the fixed character type, fixed length, which has fixed length. The n is the fixed length of characters. Now, for dealing with variable number of characters, we use variable character type data or varchar, and this n is the maximum number of characters that we can hold, we can store. So within this range, any length of characters we can store, but it should not exceed n. And then a text can store unlimited number of characters. So character types is also done. After that, we are left with only date type. Date and time is a sophisticated case. It is another type of data which is different from, though date and time holds alphanumeric. It is true that date and time holds alphanumeric value. In date we write numbers, in year we write numbers, in time also we write numbers, and beside that we write PM, AM, all those things. But all in depending on that format, you can write name of the month also. But all these are alphanumeric. But this is a specific data type, right? This is a specific data type. This is a sophisticated data type. So they created or they invented another specific data type which can deal with date time. Okay. So for dealing with date, and time, we have multiple types of data. At first, I think you have already heard about it, which is timestamp. Which is timestamp? At first, there is timestamp. Timestamp means if I tell you that can you write today's date, or can you write the date and time? Can you write to the date and time? You will write that okay, it is 15:15:554, then 08 hyphen 01 hyphen 2026. This is how you are going to write. So it holds the time also and the date. The time as well as the date. It holds time as well as the date. So we are going to deal with date and time simultaneously. We are going to deal with date and time simultaneously. That is why it is called date timestamp. This is the standard format. Okay. Now, for example, you only need date. Time is not the requirement. Or time is not required. You need only date. Then it is simply date. Nothing else. It is date. Okay. I forgot to mention the range of the data. I forgot to mention the size of the data. The size of the data will be 8 bytes. The size of the data is 8 bytes. The size of the data is 8 bytes. So timestamp can hold data information or data up to 8 bytes. Okay. Now, it is not like that all the columns or all the rows will, if a column is defined as timestamp, all the rows will hold total data less than 8 bytes. No, absolutely no. Timestamp is applicable for each and every record. Timestamp, this data type is applicable for the range of data type. The range of the data type is applicable for each and every element. Each and every element explicit separately. Each and every element separately, individually. Alright. So, what is the range? It is the time. The range of time is not matter of concern. The range of time is not matter of concern. Why? Tell me why. Why time is not, the range of time is not, we should not bother about the range of time. Why? Why we should not bother about range of time? Because time is very limited. Time is very limited. There is 24 hours only. There is 24 hours only. Though date is also time. But you know what time is. In this case, what is time? Time is the time which is displayed in the clock. The time which is displayed in the clock. Which means, now right now this is almost 4 p.m. Right now it is almost 4 p.m. So this 4 p.m. or 3:57 p.m. is the time. The date is not considered as time. That is different thing. That is separate thing. So the range is 0 to 424. 0 0 colon 0 colon 0 0 at 12 a.m. at 12 a.m. when the clock starts, at 12 a.m. when the clock starts resets, when the column resets, it's time. We consider it 0 0 0 0 0 comma colon 0 0 colon 0 0. Then it can go up to 24 24 0 0 0 0 0 0. That means this is the whole range, 0 to 24 hours. So 0 to 24 it can hold. 0 to 24 it can hold. So for time, of storing time only, we have time data type. The range is obvious 0 to 24. Range is obvious 0 to 24. It is 8 bytes. The range of time is bigger. Because it has 3 levels of precision. It has 3 levels of precision. One is hour. Bigger precision is minutes, and even bigger precision is seconds. Right? So the range is 8 bytes. And for date it is 4 bytes. Date it is 4 bytes. Because you know that you cannot write billions of years. You cannot write the range is 1, 2, 3, 4, 5, 6, 7. So you cannot write billions of years. So the range is 4713 BC, 4713 BC to 5 crore, not 5 crore, 58 million 74,897, or less than 60 million. 5.8 million, sorry, 5.8 billion. 6 million, less than 6 million is the range. Yes, less than 6 million is the range. Because you know that human civilization is not going to surpass that time, and even if it does, hypothetically, even if it does, SQL is not going to be around at that time, and you are not going to deal with some 10 million or 100 million years you are not dealing with a time 100 or 200 million years ago, or 100 or 500 million years after this one, after this time. So from now on, so the range is 4 bytes, and the range I have already told you. So you should never be bothered about this. And practically the date is going to be something maybe at most it is going to be some 50, 70 or 100 years ago, and some to 10 to 20 to 30 or 40 or 50 years after this. So date suffices that. Date is sufficient for that. Okay. Now timestamp, date, and time I have discussed. Now it is interval. Interval means, as the name suggests, what is interval? Time interval means in terms of years. In terms of years. Okay. Time interval is not in terms of time, or 3 hours, 4 hours, or 5 hours. Not like that. It is in the term of years. So that interval in term of years, and that can hold a bigger number, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. That means it can hold up to 17.8 crore. 17.8 crore, or almost 18 crore years interval. Still, it is not practical. Because we are not going to deal with, in practical, we are not going to deal with such a huge interval. Because our history of our human civilization is few thousand years. Human civilization is the history of our civilization is for a few thousand years. Some say it is around 4,000 years or 5,000 years or 7,000 years. Doesn't matter. Okay. Even the number system is not that old. Okay. So interval in times of years. So time, date and time data we have discussed. After this, I'm going to insert data. Before that, let us create the database, use the database. Then we are going to create the database and create the table. And inside table, we are going to define the data type. And after that, we are going to define the constants. Okay. Before that, let me discuss about the constants also. What are the constants? There can be multiple types of constant. What is constant? Constant is a type of restriction. Constant is a type of restriction. If we talk in a very high level, just concept of the word constant is basically some type of restriction, isn't it? For example, I'm holding this pen and I'm moving it like a pendulum. Okay, I am holding the tip of that marker. I'm tip of the marker and tip of the marker and moving it like a pendulum. Okay, then it has. Does it have any constant? Does it have any constant, or is it moving freely? Obviously, it has some constant, which is the tip of. I am holding the tip of the marker. In practically, I cannot show you any pendulum, but if you close your eye and think about a pendulum, the pendulum is also fixed with a thread. The tip of the thread is bound to the ceiling or some kind of floor or something like that. So one end of the thread is fixed. One end of the thread cannot move. One end of the thread is fixed. It cannot move. Another end is free to move. And if we start to apply any kind of force on the another end or on the ball is hanging with the tied to the thread, and if which is the free end, if we let it move, if we let it move, or if we apply any external force, it will start to move, isn't it? But the the bob can move, the ball can move, the bob can move, but the other end cannot move. The other end of the thread cannot move. That is the constant of the pendulum. Okay. If there are double suspended double pendulums, then there is one pendulum hanging, and from that pendulum, another thread is. I know this is very hard to imagine, but another thread is bound there, and there is another metal bob hanging from them. Okay. Now you start to move it. It will move in a butterfly. Gradually, it will create a butterfly shape. That is different thing. That will be very random motion. Still, there are constraints. Though it is very apparently, you think that the second pendulum is much more free. Yes, that is much more free, but it is not completely free. Why? Because other end is tied to the first pendulum, and the tip of the first pendulum, or the tip of the thread to which the first pendulum is tied to, is tied or bound to a fixed point that cannot move, and that is why the second pendulum is restricted, and the second pendulum the first pendulum is restricted, and the second pendulum is also tied to the first pendulum. That means that the second pendulum is also bound to the first pendulum, or the motion of the second pendulum is also dependent on the first pendulum. That is the constant. Very complicated constraint. Okay. Now, in real life or in case of data, we can also have constraints. What kind of constraint? Okay. The constraint is regarding data can be where do we store the data? Inside columns. Inside columns we store data. The column should have constraints. Now, one constraint is null. Okay, no. Before that, there is something called primary key. There is something called primary key. Primary key. What is primary key? Primary key is basically a key value. Key value. Key value means it is a unique value, isn't it? Key. Key means very important. If something is very important, you want it to be unique. If something is very important, you want it to be unique. For example, if some column is primary key, that means that each and every record must have that value, associated value. For example, in a class, I am creating a table called classroom. I am going to create a table called classroom. In classroom, I am going to create columns. One is rank, another one is name. Rank and name. And then there can be age also. But name and age can be same. In many cases, we have few students in a class who have the same name, or we can we can call them to be a namesake. Namesake. The word namesake is used for that. If two people have same name, we call it a namesake. So that is practically possible. That is practically possible. But in a class, there are 100 students and two students have same roll number. That is not practically feasible. You can assign same role, but that is not useful, isn't it? Ideally, we assign unique role. Ideally, we assign unique number to each and every student to identify the student with that particular number. Name can be same. For example, there is one student called Lionel Messi. There is one student called Lionel Messi. There can be another student named Lionel Messi, but this Lionel Messi is roll number 10 and that Lionel Messi is roll number 7. So roll number 10 and 7, whenever I am going to call roll number particular Lionel Messi, I will call roll number 10 Lionel Messi, roll number 10, or simply roll number 10 or roll number 7. It will not create any conflict. But if I call it Lionel Messi, both will come and ask, okay, sir, did you ask call me? So roll number is the unique number. So roll number is the unique number which is very unique for each and every student. So it is a fundamental number, or it has to be unique for each and every member of the class or each and every student. Like that, in the same manner, primary key also is the unique number or the column which has to hold the unique value for each and every record. That column is defined as primary key, or this primary key constant is used for that column. Okay, in that case, in this particular case, I will write rank column. After rank, I will write the data type, which is integer or big int, whatever. Then after that, I will write primary key, this constant primary key. So this is the unique number. It is unique for each and every record. Okay. Then there can be foreign key also. What is foreign key? Foreign key. For understanding foreign key, we have to practically understanding foreign key. We have to talk about schema. I can tell you the definition of foreign key, but if I want to show you dealing with multiple tables, then I have to talk about the schema. Concept of schema. What is schema? Schema. What is schema? For example, as I told you, there is a database. It holds very multiple number of many tables, multiple number of tables. But ideally, in practical life, if you are doing something, these tables. You are just creating tables and inserting data, and then moving to another table and creating another table, then inserting data. It is not going to work, isn't it? If you are going to perform something important, then these tables must have some kind of interrelationships. These tables must be connected to each other in a way. Or if you're practically dealing with any project, or you're practically performing something, then all these tables are not independent ideally. Maybe these two tables are mutually exclusive. Maybe two tables are mutually exclusive, but those two tables must be related to some other table, ideally. So, if all these tables are connected, somehow connected to each other and creates a structure, that is called schema. All these tables are connected to each other in a way, and they are connected to each other in a way and creates a structure, then it is called a schema. So there can be two types of schema mainly. One is star schema. What is star schema? We know that the structure of star, we are writing select star from table name, right? Select star from select all from for fetching all data. We are writing select star from table name. So this star is that symbol of star we know. The structure of star we also already know. So look at the structure of the star, symbol of star. Crisscross. All the lines intersect at the center. All the lines intersect at the center. Right? So the structure is also same. There will be a table at center, and there other tables, there will be multiple tables connected to that table around it. How? Okay. So in practical life, this central table, in practical life, this center table is called fact table. Fact table. And all these tables around this is called dimension tables. Dimension tables. Why? The name fact suggests that it holds the facts, which means it holds the most important parameters. Other stuffs can be stored in all the dimension tables around it separately. But the main, if I give an example, practical example, for example, there is a pharmaceutical company. And in pharmaceutical company, you have customer database or customer table, a table that deals with customers only, customer information. So this is customer table, cast table, cast. Let me write cast only, cast. And this is the. Let me remove. These are too many tables. Let me remove other tables. I'm dealing with 4 tables only. Okay, I'm dealing with 4 tables. This cast table, this is policy table, this is policy regarding the company. This is the product table, and this is another table regarding HCA. Or HCP. Okay. Hospital related policies are there. I'm just taking few generalized examples. Now, there must be few very important or the parameters or key parameters that are very unique and very important for this table policy and for product table or cast table. For example, for cast table, this is cast ID. This cast ID, cast underscore ID. And for policy table, it is pol underscore ID. And for product table, it is prod underscore ID. And for HCP table, it is HCP underscore ID. These are the most important tables. So fact table must contain these tables, these parameters. The fact table must contain these parameters. And using these IDs or these unique values or parameters, the dimension tables, all these policy, customer, product, and HCP tables are going to be connected to the central fact table. And this fact table will hold all these parameters. So this policy ID or pol ID is primary key, basically the primary key to the policy table. Customer cust ID is primary key to the primary customer table. Prod ID is primary key to the prod table, and HCP ID is primary key to the HCP table. And this fact table is pharma table. Okay, this fact table, for example, this fact table is pharma table, and this pharma table has pharma ID, which is pharma ID is obviously pharma ID is one of the primary keys, but it also holds this prod ID, pol ID, cust ID, and HCP ID, which are the foreign keys, to the fact table. And using this pol ID, this policy table and fact table will be connected. Okay, so the primary key of to policy table is foreign key to the fact table. Understood? This is the concept. And in similar way, there can be another structure also. In that case, I am not going to give same example. I'm just going to show the structure only. That is snowflake structure, snowflake schema. Snowflake schema. What is the structure of snowflake? If you have seen the snowflake logo of snowflake, then you will understand what is the logo. What is the structure of snowflake? If you have seen any. If you have seen the Frozen animated movie or anywhere in WhatsApp also, you will find the chill or cold emoji, which is like this, which looks like this. Initially, it divides in a manner like a star, but all these branches also have sub branches. All these branches also have sub branches. So this is the structure of a snowflake. Okay. Previously, I tried to draw this, but that didn't look so good. But this looks legit. This looks legitimate. So this is the snowflake structure. So the structure will be same. It is a fact table. There are multiple dimension tables connected to it, and these dimension tables are further connected to multiple dimension tables. This is the snowflake schema. So in large projects or in practical life projects deal with snowflake schema very frequently. Mostly they deal with snowflake schema, because those dimension tables can also be connected to other tables which are further divided into dimension tables. Okay, now I'm going back to the first example. I'll go back to the first example, then I'll create a database. First create database. I'm taking the same first example, create database, okay, create database. Book, create database book. Okay, book database is created. Now to dive into this database or use the going into inside this database, we have to write use book or name of the database, use book. Now we have immersed into the database, which is book. Now I'm creating a table. Create table. INDX, create table INDX. INDX, sorry, not colon. Okay. Now open bracket. I'll write column 1. I'm not going to write col 1 now. That was on a high level. That was a structure. Now I'm going to create a real life table. So what I will write? The structure of the index is holds chapter name. So chapters. Chapters is the first table name, and the data type is going to be, the data type of what kind of data is stored inside the chapter name column. The name of the chapters. Usual, I don't have to write text. Why I don't have to write text? Because the index doesn't hold huge lines, isn't it? So at max it is going to hold 3, 4, 5, 6 or 7 words, right? So I can easily take it varchar. I can easily take it varchar. Varchar 50 or varchar 100. Okay, varchar 100. Varchar 100. I am taking varchar 100. Now, next is page number. Page underscore now no. Page underscore no. Page number. This is a table name, and the data type will be. We know that the data type will be integer type. You can take decimal, no, integer, because the page number is usually integer type of data. So I am taking int. Okay. I cannot take serial because it is the index. So in case of each and every page, I'll take it serial because it will auto increment. But for index, the page numbers will not increment one by one. After 1 there can be 10, then after 10 can be 57. So I have to take. I have to mention the value. So page number integer. Okay, now I can have constants also. As I told you, I can have constants also. So for chapters, is there any constant? Yes, there is one constant which is not null. Not null constant I did not discuss, but I am now telling you what is not null. As the name suggests, not null. Null means what? Empty. Null means it doesn't have any value. Empty. But null means zero. But in case of data, what is null? There's no record. It's empty. So this row, under this column, chapter column, all the rows should have value. Inside index, all the columns should have values, isn't it? So it is not null. Not null. If we want it to be by default, we want it to be null. By default, we want it to be null. Then we'll write null. Not instead of null, we write not null. We'll write null. But right now we want it to be not null. We don't want it to be null. So we have written the constant not null. Now page number integer. Now I know that page number is the unique value. Though in case of index of a book, two chapters should not have. They can have same word, but they should not have exactly same name. There cannot be two chapters of same name. So we can take it to be we can consider it to be primary key, but it is better to take page number as primary key because primary key is a number, unique value. So page number is unique for each and every chapter. There cannot be two chapters cannot have same page number, or there cannot be two chapters. Yes, there can be two chapters in a page also. That is also right, but usually it doesn't happen. One chapter, ideally it doesn't happen, but okay, maybe one chapter is half page long. One chapter is half page long, so it will start on the stars or at the beginning of the page, and it will end at the mid of the page, and then another chapter will start. It can happen, but it is not ideally. It doesn't happen ideally. So I am taking page number as primary key to show you. Now primary key. This is how you write primary key. So page number in primary key, and also not null you can write not null because page number cannot also cannot be null. And then close the bracket and so the chapters is bracket 100 and not null constraint is there. And page number is integer type. It is the primary key, and not null. It is also not null. Okay. Now I've created it. Let us. I'm just removing everything because insert statement. The structure of the insert statement is consists of more keywords. It will take space. Okay. So insert. Now after creating the table, we will insert data, defining the table column data types. Data types of all the attributes and their constraints. Now I am going to write insert it. Insert into data type. What is the data type? Insert into insert into the table name. What is the table name? The table name is index. Insert into index table. Very good. Now after that, values. Insert into table name index. After that, values. One thing you can do for insert statement, you can directly write insert into index, then values, then next time values, then you can open the bracket, close the bracket, and inside this bracket you will write the values you are going to insert in the same order as you have defined it while creating the table. As you have defined it while creating the table, in that same order you can write. In this case, we have two columns, so you can write intro within quotation intro, and the second value is number, so quotation is not required. So you'll write comma 1. Okay, then you'll write what is SQL, what is SQL, quotation close, and then 3, like this. But for example, you are going to insert data into some specific columns, or there are many columns, and you don't want to mess up the thing. Then you want or you forgot you don't want to memorize the order of the columns, or you don't want to mess up with the column names, order of the column names. Then you can simply write in this way for insert into the index. Then within column bracket you have to write the or chapter names with the bracket chapters. Sorry, the column names chapters. Okay, you're writing chapters. Then comma you write page numbers. So this is the order you are going to follow after that while inserting. Now values. Okay. Now chapter intro. You cannot write, now you have written chapter comma page number, so you cannot write page number first. Okay, intro comma page number is 1. Fine. Again, after inserting each and every value, record, you have to write inside bracket the records are also comma separate. After writing each and every record, each and every entry, you have to provide another comma to separate all the records from each other. So after closing the bracket, comma, then again open bracket, then write what is SQL, what is SQL, comma, quotation close, comma, and then 3, bracket close, again comma, then next chapter name, comma, page number, and so on. Fine. Now, select statement, if we run select, again I am going back to select statement, select star from the same index, same syntax I am going to repeat, select star from index, display all the records, all the columns and the corresponding records that we inserted. So select star means select all. Now, for example, I just want the chapter names. I just want the chapter names, which doesn't make sense. In case of indices, we must have both the columns, individual. But for example, they just want to know. I am not concerned about the page number. I am not going to read that book. I just want to at first, if you are going to buy a book, if you are going to buy a book, you can turn the pages, but you cannot read the whole book. So in general, in practical life, what we do, we go to the indices, we go to the index page, and we read the chapter names. What this book is all about. What are the chapters contained into this book? What are the chapters that this book consists of? Okay. So in that case, I want to fetch only chapter names, chapters. Select chapters from index. Then colon. This colon is not required. If you select only this statement and then run it, okay. Otherwise, if you directly run, and there are multiple queries inside the same panel, same terminal, then it will create ambiguity or conflict, or it will throw error. That is why after completing each and every query, you have to write a semicolon. This is a good habit. And the last query should not, for the last query it is not mandatory, because after that there is no query. So obviously after the last query, if there is nothing after that, then even if you forget to write the semicolon, it is not going to throw error. But usually it throws error. Okay. So the writing this semicolon is very important. Select chapters from index. Fine. Now, this is the select statement. I think this is enough for today, or at least for this video. This is enough for this video. In the next video, we are going to dive much deeper into SQL, and we'll discuss about. In the next video, it will be faster. The learning process will be faster because we have understood the basics of the SQL concept. I don't have to keep repeating the same thing, or I don't have to be I don't have to explain it so childish manner. Okay, so on a high level, I can recapitulate it on a very high level. If possible, I will recapitulate it. Then after that, I will move to the next topic, which is basically the mathematical operation. After that, all the data types we have understood. The constants I have understood, the structure of table data and how to create it, how to create database and how to use it, how to create a table, how to insert data inside it, how to define the table, and after that we are inserting the data, and then how to select or retrieve the data or display the data. This much we have covered, and what are the data types and what is schema, what are the types of schemas, and what is primary key, what is foreign key, not null, all these constants we have discussed. So all these things we have already discussed. Okay, now in the next chapter we're going to discuss about the next thing, which is mathematical operation. And after mathematical operation we'll go to logical operations, and then maybe if time permits we will discuss about conditional statement, which is where clause, and use the logical and mathematical operations inside that, and then we'll move to aggregate function. And whenever we are reading aggregate function, we'll move to the conditional statement. For aggregate function, we will go to grouping the values, and after that, after group by, I'll move to having clause, which is the conditional statement for aggregate function. And this is the basics of the SQL. Okay, so next day we'll cover the basics of the SQL, and then we'll move to joins, which is intermediate level or most important topic. Joins we'll cover, and then after joins we'll move to what is it? After joins, I think. No, CT is very advanced. Views and CT will keep it for end of the course. Okay. After joins is the most important. Yes. After joins we'll discuss about dense rank, rank and row number, which is the window function. Window function we'll discuss. And there are some specific functions also which is very unique for PostgreSQL, which is the name of the functions vary from database to database, but we can discuss about that also. And there are some. This is a book, Practical SQL by Anthony Devaros. Devaros. Okay, this is a very good book and very user friendly. This book consists of many other things, some statistical functions and everything, something like that, and many other things which I haven't even touched. Okay, even I haven't touched. So CT is also there. I think CT is also there. Maintaining database. If someone want to buy a good book, you can buy this book. But these books are very costly. Okay. What is, you can buy it. Yes, saving time for with views and functions and triggers. Yes, views is also there. CT and views. Views is basically a temporary table. Views is basically a temporary table. You have queried something and you have displayed a value or a table output, and temporarily you want to store it as a view. Temporarily you want to store it and display it later. Then it is view, and there are multiple types of views. And in CT, what happens is that you are running the same operation or say same query, same types of query on daily basis or multiple times. You don't want to write it repeatedly. Okay, or series of operations you are going to perform repeatedly, and you don't want to write it repeatedly. Then you store it as CTE, common, uh, one second, common table expression, CT. You want to store it as CT, common table expressions. So the whole expression, or the one, two, three queries, whatever you want to repeat on uh, on a daily basis or multiple times, and you don't want to write it again repeatedly, then you can store it as common table expressions or CTE, and later on you can call the CTE and perform the same thing. So this is very important. CTE, in most of the cases, when the interview is on SQL, um, they are going, if the person has a decent amount of experience of 2 to 3 years, 3 years of experience, then they will ask you about CT in most of the cases. So okay, this is it for today, or this is it for this video. Hope you like it. If you like it, then click on the like button. If you find it useful, then share with your friends, and don't forget to subscribe. Thank you.